Okay, so we're going to look at the same purchase order data that we did before, but now we're going to look at the measures of dispersion of the data, in particular the range and the standard deviation, which are kind of core to the statistics work that we're going to do next class. So I've actually put this data again on another page. Now, to make things simpler, let's just select this, Shift, whoops, go down a little bit, then select again. So we basically want to select all the rows except maybe the first 5 and the last 5. Go to the home page, go to the home tab, go across, then go to Format and hide and hide rows. So in reality, all we're doing here is we're just making it a little bit easier to deal with. Now I'm going to copy and paste this across from my completed version. This is just some of the headings. And we're ready to roll. So the idea of the standard deviation is we're first going to calculate how far away we are from the mean. How far each item is away from the mean. I could have going back to my original my silly little example, where we kind of had our online reviews on a scale of say 1 to 10. Just so imagine we have these reviews: 1, 2, 4, 5, 7, and 8. And then we have 4, 4, 4, 5, 5, 5. Now both of these, so let's just calculate the average, have exactly the same average. Both have an average of 4.5. But you can see the first ones, are much more spread out. So even from a business context, if we're looking at this data, they both have the same mean, but this restaurant obviously just gives consistently mediocre service. This restaurant sometimes gives really good service and sometimes gives really bad service. So they have, with the same mean, they have different performance characteristics. This one has much higher variation. Okay, so how we calculate the variance and the standard deviation, we're looking for how far each value is away from the mean. So say, for example, here, this would be, if the mean is 4.5, this would be 3.5 away from the mean. This would be 2.5 away from the mean. This would be 0.5, 0.5. Again, 2.5, 3.5. And you see each of these would be 0.5 away from the mean. So we want to work out how far things are away from the mean. So all we're going to do is first we actually have to calculate the mean. So it's going to be average. And while we're here, we're actually going to count the number of items because we're going to need this in a minute. Be careful not to go down to the average. So we have a mean of order, which you've already calculated, of $26,000. And all we're doing is we're working out how far each of these individual items is away from that mean. So we're going to do the item here, which is just xi. We're going like I equals 1 to the number of items. This is the value for the items. Subtract from the mean. Now, let's just put, I don't think we're going to take it right, but we'll put an extra dollar on. We're just going to do $1 as we're going to drop it down. And this is the distance from every item to the mean. Now, the problem is some of these are negative and some of these are positive. So when we add them up, they're all going to kind of cancel out. So what we do, you could actually take the absolute value, but generally in statistics, we square it because certain things work out nicer. We're just going to square each of these values. So this is just going to be that value to the power of 2. And let's just put it across is going to be a very big number, and then we're going to drop it down. Even bigger numbers. So these are the kind of the squared errors. Now, what we do is we want to calculate to find out how much variation we have. We just calculate the sum of all these squared errors, which we call the sum of squared errors. I'm going to drop this down here. And this is, again, a very big number. That's the sum squared of all of our errors. Now, the thing is, this value gets bigger and bigger and bigger as we have more and more items. And we want some measure that's kind of independent of the number of items. So we just divide by the number of items. And this is the variance. So let's just kind of divide this by the number of items. And this is kind of the amount of variation. Now we also, if we take the square root of this value, we get the standard deviation. The standard deviation can just be interpreted as, you know, the kind of the average amount of variation in the data set. So we're going to just go down one, and we're just going to square root. And this is the standard deviation. We're standardizing it. And this is basically because we squared every value, we're now going to go in the opposite direction, and we're going to square root the total. Now, and this when we get to statistics, and this is a little bit beyond this class, but if we're doing in statistics and we're calculating in terms of a sample, we divide by n-1 rather than n. This is just to account for the bias in the sample value. Now, for simple descriptive statistics, it really does not matter which of these we use. But we just think population variance we divide by n, sample variance we divide by n-1. So we can actually, we'll do the same. So that's population variance. But now we divide by n-1. And there we have it. And you can see it's a little bit larger because we divided by n-1 rather than n. And we're going to square root. And again, very similar. Now, Excel actually has built-in functions to do this. We've got the variance dot the population. And I'll just kind of copy that for future reference. We have the standard deviation for the population. So we just stdev. And you see you have these versions, .p for population, which again, you see these numbers are the same as those numbers. Then we have it for the sample. And the standard deviation. Okay, and let's just, obviously we can't format the count, but let's just kind of format these as a currency. So select, right click, format cells, currency. What happened there? Format cells, currency. There we go. And that's the variation and standard deviation. And let's just kind of, for a bit of fun, let's just do the variance of these two. So let's just use the population. As I said, at this stage, it really doesn't matter. So you see the variance for this data set is 6.25. We drop it down. The variance is 0.25. And the reason for this, if you think of each of these values, 4 minus 4.5 or 5 minus 4.5, they're each going to be positive or negative 0.5. Square 0.5, you get 0.25, which are always going to be positive. You add them all together, multiply by 6. But then you kind of divide it by 6, which is the n, so you're left with 0.25. And then the standard deviation. And then kind of do the standard deviation. Let's just see. Drop down. And there we have the standard deviation, square root these values, 2.5 and 0.5. Okay, so that's it for that little example. We kind of went through, we calculated the variance. You got a bit of the intuition. You can see how far it is away from the mean. You square it. We need to account for the size of the data set, so we divide by n if we consider it to be the population, and n minus 1 if we consider it to be a sample. In this kind of context of data description, it doesn't really matter, but when we get on to do sample statistics, we'd want to use the sample variance and sample standard deviation.